Hello, in this video we're going to look at two-dimensional arrays. Two-dimensional arrays. Although most of what we look at about two-dimensional arrays will apply to higher dimensional arrays. I'm assuming that you're familiar with one-dimensional arrays, which we'll do a very quick review of. If I'm declaring an array, let's say it's called A, to be an array of integers, I write that out as int, which is the type of my element in the array, and the brackets tell me it's an array. And I'll go ahead and create such an array. It's a new array of, let's say, 5 elements. And then I can start filling in those values. Right, the index is start at 0, and I'll put a 3 there. And I think that's enough to get the hang of this. So we'll draw a little picture of that array. Here's A, and it's referring to an array of 5 positions. 1, 2, 3, whoop, these boxes are not particularly even, but that's okay. Index 0, 1, 2, 3, 4. And apparently we put a 3 in this particular box, and I don't think it's critical that you know this, but when you create an array of integers, what you get is a bunch of zeros. So all of these other positions that I didn't initialize, I haven't shown you initializing, are storing zeros. And of course, if I want to find out the length of this array, then I write a.length, and I'll get back the answer of 5. Or we could just write that the nice way. There we go. Okay, so that's a one-dimensional array. It's one-dimensional because there's only one dimension. It has length, but it doesn't have, say, height or width or whatever you want to call it. Two-dimensional arrays, by contrast, are wonderful for representing anything where you would want a grid. So think about if you were implementing your own Minesweeper game, or your own game of chess or checkers, or any game that takes place in a two-dimensional grid like this. How about like this? There we go. So we'll have 3 rows and 4 columns, and they're going to be indexed again the same way. This is column 0, 1, 2, 3. And this is row 0, 1, 2. So in fact, let's indicate rows and columns very clearly. These are my rows, and these vertically are my columns. So I have 3 rows and 4 columns in this grid, and I don't know what I'm using it for, but so this is a two-dimensional array. And let's say I actually decide to call that grid G. So I'm going to have a variable G, and G is going to refer to this big two-dimensional array structure here, and I want to know what is the Java code to create that structure. And we'll assume these are storing integers. So maybe if they're integers and I haven't actually changed the default value, they will default to all storing zeros, like that. Let's look at the code to create that thing. Here, whoop, let's keep that on the screen. Okay, what is the code to create that thing? Well, I'm gonna write that I have integers inside my array, and it's an array, so I have brackets, but it's a two-dimensional array, so I will have 2 sets of brackets, and my variable is G, and I will initialize G to refer to a brand new two-dimensional array. And so just as before, where I write my variable refers to a brand new array of type int, and inside I write the number, which is the number of elements. Here I have 3 rows and 4 columns. So I'm going to make the row number over here. So this is number of rows, and this is the number of columns. Now that's actually technically a convention. If I decided that the first number should be the number of columns and the second number should be the number of rows, and as long as I'm consistent throughout my entire program so that this refers to the column number and this refers to the row number, I could do that. But I prefer to use rows and then columns, so I have 3 rows and 4 columns, and I will make sure that whenever I refer to this first index, that refers to the row number, and the second index will be the column number. And a little warning, if you like, instead of using rows and columns, if you prefer to use X and Y, you should know that X is are like columns and y's are like rows. That may be something that trips you up when you, for example, you work with rows and columns for a while and then you look at someone else's program where they use x's and y's instead. Just take a good look at that. Be aware of that difference. Okay, so now I want to start storing values in this. Then I write, if I want to put let's say I want to put a value over here. I want to put the number 3 in that last bottom right cell. Then I would write g of row 2, column 3 should store a 3. And then we will get a 3 over here. And likewise, we can access, we can later say, you know what, I'd like to print out the value that's in G23, and it will print out that 3 value I just stored, and so on. Okay, now I want to take a look at what's really going on here. How is a two-dimensional array really implemented in Java? Because there's some surprising aspects of these things. So notice with my original array, it's an array of int. So the thing before the brackets is what the type of the elements in the array. Now here, I have, looking at these brackets only, this tells me I have an array of arrays of integers, which means a two-dimensional array, in fact I think this is important enough, I'll write it out, a two-dimensional array is really an array of arrays, right? We've had arrays of integers, arrays of strings, array of objects, arrays of booleans, and so on. Now we can have arrays of arrays. So really what's going on when I make this two-dimensional structure here with 3 rows and 4 columns is that I'm making an array of arrays. Let's look at that array of arrays. So here's G, and G refers to an array, and I'm drawing this array vertically because it's going to let this picture line up in a nice way. This array has, let's see, indexes 0, maybe we should change color for that, it's getting too crowded here, 0, 1, 2. What's in this array? Well, it's an array of arrays, so I have arrays in them. The arrays inside it are length 4. Let's see, right? Maybe I made this too big because now you're going to have to watch me draw out all of these little boxes. That's okay, that'll give you time to think about arrays and appreciate how beautiful they are, and appreciate how much better you would be at drawing boxes if you were faced with moving your mouse in this fashion. Okay, so each of these boxes in the pink array refers to one of these 4-element yellow arrays over here. I guess we'll number the indexes there too. So this thing this part in blue is what I think of as my grid, like this, my grid of integer values. And I guess we could actually stick the integer values in. Let's go ahead and do that. This stored a bunch of zeros before, because that's the default integer value. But in the bottom right, we decide to store the number 3 on this line here. G23 gets the value 3. Okay, so let's look at this again. The G is really an array of integers. And now I can see that G refers to an array, and that array contains arrays of integers. This line I think is, it's hard to interpret this line in that sort of way, but let's look at another line. G2, 3. What is G2? If we write G2, what is the value of G2? We know the value of G23 is 3. Right, value of that, I don't know how I want to write this, value of this is 3. What's the value of G2? Well, the value of G2 is this array here, this entire array. So G2 is an array. Refers to an array. It refers to this array with a 3 at the end. And so when I say G23 gets the value 3, what I'm saying is G2, which is this array, now ask that array for element 3, and that's over here, and store, or ask for the box corresponding to index 3, and then store the number 3 in that box 3. That's what's happening here. If I use that idea, then we can learn something very clever, which is how do we find out how many rows or columns are in an array? So let's do that. How many rows are in G? How do we determine how many rows are in G? Well, G is this array, right? And if I asked for G.length, G.length would be 3. And 3 is the number of rows. So I can determine how many rows are in my two-dimensional array by asking for the length of one of those, for asking for the length of my larger array, which is what G really is. Sorry, excuse the wiggling here. Okay, then we say, let's ask how many columns are in G. How do we determine how many columns are in G? Well, if I want to know how many columns, the answer is 4, and 4 is the length of each of these arrays. So if I could just get one of those arrays, and so let's get the first array, that's G0. I get that first array, and I ask it for its length. That tells me how many columns I have. Now I've made some assumptions here. I'm assuming all of these arrays are the same length, and they are if I create them in this fashion, but there's nothing to stop me from making a sort of jagged two-dimensional array where it's an array of different length arrays. In practice, I haven't found that to be a useful thing to do. 99% of the time when we make a two-dimensional array, we want a rectangular array like this. Every array within the larger array is the same length. And so you can ask the length of any of the smaller arrays, any of these, if you want to know the number of columns in the overall array. So G0.length is 4, but so is G1.length and G2.length. But G0.length is a good way to go because anytime I'm working with a two-dimensional array, I will most likely have already confirmed that there's at least one row before I run this line of code. And I might not know that there's 2 or 3 rows, therefore it might not be safe to say G1 or G2, but G0.length is almost always going to be a safe thing to write as long as I know that there's at least one row in my array. In the next video, we'll take a look at how to actually use two-dimensional arrays to solve some problems. We'll look at some simple problems that work with two-dimensional arrays, and I'll see you in that video.